In this video, we're going to smoothly make all these cubes go back to where they started. So it's kind of falling apart now, and they're going to suck back together and go back to where they were smoothly. We're going to use vector3 lerp and quaternion slerp. So it's like a smooth transition function. So we're going to right click, we're just going to add a script, call it return to start. Just add this to anything you want to return to start. In this case, this purple cube makes more of itself, so they're all going to have return to start, but just add this script to any kind of rigid body or whatever that you want to go back when you press a button. And open up that script. Okay, the first thing we're going to do is have a way to keep track of our start position and also drift position, which is going to be the spot where we started to drift back. I'll draw a picture for this in a sec. And drift rotation. Okay, so say this green square is where we start, and then this red square is where we drifted to, and this purple square is where we are. So, transparent. So let's say we start here, and then we get blasted away. So we're going to drift away. The green is is our start position, and this purple is where we are. And right here, let's say, oh, bam, right here, I decided I want to start drifting back to where I was. So this purple cube over 3 seconds, I'm going to say 3 seconds, is going to smoothly go back to where it was. But in all that time, we do need to know where we started and where we ended up, because it's going to be a smooth line between these two, and we need to remember that. So when we start, our start position, we need to remember it, because transform.position is going to change. Same with rotation. Now we need two functions. There's start drift, is when we decided we're going to start. Oh, actually up here, we're going to need public float drift seconds, as I said, can be 3. We need a drift timer. It's going to be from 0 to 3. It's going to start at 0. That's how long we've been returning to our original spot. Private bool is drifting. That's just if we're drifting. So when we start the drift, is drifting is true. Our drift timer, if we've maybe used it before, so we got to put it back at 0. Our drift position is going to be where we are right now. So just when we started to drift, that's where that point is going to be, just like in this picture. So we're going to save this red circle up here. Next, we need private void stop drift. Okay, is drifting is going to be false. False. And then we're just going to make sure that we really did go back exactly to our start, and we really are going to go back exactly to our rotation. So it's not just barely there almost, it's like exactly there, because we're going to smoothly go there. What else? That should be good. So an update, we're going to check. Update happens every frame. It happens a lot. We're going to check if we pressed the button. Get key down. There you go. How about we press K? Then we're going to start the drift. If we are drifting, we're also going to have a whole bunch of stuff going on here. Drift timer is going to go increase by delta time. That's how many seconds have passed since update was last called. So it's going to be like 0.5, 0.05 or something. If drift timer is greater than, drift timer should be between 0 and 3. But if it's greater than 3, we're actually going to stop drift because we're done. Otherwise, we are drifting and we have to use it. So the way this is going to work for lerp and slerp is we're going to draw a line between these two and say we're at 1.5 seconds. That would be right in the middle. So 1.5 divided by 3 is 0.5, it's 50%. So we're going to tell that to the lerp. We're going to give it this point, we're going to give it this point, and we're going to tell it 50% or 75% or 21%, and we're going to get a point from that. So that percent is, I'm going to say ratio. Drift timer is 0 to 3, and drift seconds is always 3. So that's that ratio. And then my new position that I want to set it to is going to be vector 3 lerp, and you got to give it 2 vectors, or 2 positions and a ratio. So from is where we're starting, that's that drift position. 2 is where we're going to, is start position, and the ratio. And we're going to do a very similar thing with rotation. It's really the same thing, except quaternion, that's slerp, and now drift rotation, you have to give it 2 quaternions, which is 2 rotations, and again a ratio. Okay, so this is pretty good, but it's not perfect, but it's pretty good. I'm going to save it. Okay, so back in Unity, and it's there, it's added, so when I play, they're there, you can blast them away, and when I press K, they go back together. But, boom, they exploded again, because the rigid bodies are kind of being forced to go there, but they still have that velocity, and they're breaking away weirdly. It's kind of neat, but it's not, I want them to stay there, right? So I am missing one thing, 2 things, in start and stop. So we need to add something in start drift. We're going to get a rigid body. It's going to be game objects, get component rigid body. So if we actually got a rigid body, we're going to set the velocity to 0. Velocity is a vector 3 though, so it's got to be 0, 0, 0. And I'm going to constrain it. This is, I think, Unity 5. I think. Otherwise, it's done differently in earlier versions, but I'm going to freeze all. So rotation and position on X, Y, Z, and everything is frozen. But now it's really frozen forever. We need to put it back. And, well, I'm copying code here. Maybe I'll show a better way to do it after. And all we got to do is restraints is none. Yeah, I could have just made a function and you give it a rigid body constraint, because this is obviously really repetitive. But if you ever see code that's the same twice, then you probably should make a function. 3 times definitely. Okay, it goes apart. I press K, and yeah, it's back together. I can blast it apart again. This big guy can go very far away. And then when I press K, it's going to move really fast to come back that fast. All right. So that's how you use lerp and slerp. Lerp and slerp. Cool.